Hello and welcome back, everyone. This is the second video in a multi-part series about the Anomaly Drones Dragon. In the first video I did the overview of the machine itself, and in this second video we'll begin the build. And here in front of me I have the components that I'll be using to build it. We'll discuss those, and as the video progresses I'll talk about the various methods that I use to build it and the reasons behind why I'm doing it the way I'm doing it. I'll try to impart any knowledge that I have that I've learned while building this on you guys, so that if you go through the build you can avoid any pitfalls I may come across, and hopefully that'll save you some time as you go through your build. As you probably know from the first video, the Dragon was designed to use the KISS suite and the ProSight HD system. In addition, I've chosen some Luminaire motors and a Luminaire PDB to use. And as I go through the build, the basic flow will go something like this. First, I'll be disassembling and filing some chamfers on the frame, as I discussed in the first video, especially where the wires pass through the frame. Then we'll start with the Luminaire PDB. We'll discuss the prep and the placement of that. And then we'll do the same for the ESCs. There'll be some wiring that we want to pre-attach to the ESCs. We'll talk about prepping the flight controller, figure out where we're going to put the buzzer and the receiver, and then we'll proceed with mounting the PDB, mounting the ESCs, mounting the motors, mounting the flight controller, installation of the receiver, installation of the antennas, installation of the transmitter, and finally the installation of the camera. And then I guess once we get all that done, we can discuss the last thing, mounting the battery. So first, let's take this guy apart so that we can get it down to the bare frame and start the filing process. I'm realizing something as I do this. This little guy is very easy to take apart. Okay, so now we're down to the bare frame, and I just want to mention real fast what I'm going to do here. It actually looks like the edges of the frame, the outer edges of the frame, are sort of already chamfered. Well, at least they're not sharp, which is great. I don't know if that was done in the machining process or not, but it's quite nice. And for those of you that want to put a little CA on the edges of the frame, this would be a perfect time to do that. I don't know if I'm going to do that or not. I might just do it around the outside of the arms here, because that's where, you know, they tend to hit things and the carbon can fray from the impact. And I've heard that a little bit of CA can help to prevent that. Although I'm not 100% sure I believe that, but that's what everybody says. It doesn't hurt to do it. It doesn't take long. But if I zoom in here, you can see that where these holes pass through the frame, the edges are pretty sharp. So I'm going to want to go through there and kind of round those out. And it won't take me long. I've got a little round file that I'll just use to take care of that. And then same here in the back. And then the battery wires actually pass through the bottom as well in the back. And so I'll need to make sure that I round those off nicely right here, because the battery wires will be coming up to the PWB, going back down through to where the little XT60 connector mount goes. Right here, like that, which is brilliant. So that will be my main focus here, is to chamfer the areas where the wires pass through. So I'll get started on that now. Okay, we're all chamfered up. If we zoom in here, we can see what I've done. See on the top there, I've got some chamfers. I've chamfered those holes so that as the wires come out from the motors and pass through the frame, they have a little bit of a chamfer to go around that bend. And I did the same thing on the other side, where the wires come down through the bottom and they go into that channel. It's chamfered. Oop, look, I missed one. And we're back. And so I've got little chamfers on either end of the channel where the wires pass through. And in the back, like I discussed, I chamfered. I actually used a countersink tool, sort of just chamfered those guys so where the battery wires come up and go to the PDB, they don't chafe on those edges. I also went around the outside and I did chamfer the edges a little bit more. If they were chamfered, it was very slight, so I just put a slightly better chamfer on there. So next we'll talk about the PDB. This PDB is a very basic one. As you can see, it's got some large pads for the battery. It's got a couple of aux outputs, but the second aux output here, number 2, is really designed to be used with the Pololu, and I don't need that because I'm using the ProSight system. So I will be using aux 1 to power the ProSight system because those two pads are tied directly to these two pads. And so it'll just deliver battery power directly to the ProSight, which is just fine for what we're doing. And then we've got 2 pads for each of the ESCs. So the next thing we'll be doing is tinning all those pads. Is this the ugliest soldering block you've ever seen or what? Pretty bad, right? Does the trick though, it won't catch fire. And in addition to soldering the PDB, or pre-tinning it rather, I'm going to attach a couple of leads to this XT60 connector. This is the little fairing that goes on the underside of the machine. So these wires will come through these little channels and up through the frame. So I've soldered my wires onto my XT60, and as you can see, it fits into this little channel in this underside fairing. It just slides right in there. And the wires go into these 2 channels and pass up through the frame, like this. Here's the XT60 fairing mounted on the bottom, loosely. As we turn it over, we can see the wires are passing up through the frame. And I've got a couple of choices here as to how I mount the PDB. I could mount it with the battery leads or battery pads toward the back, or I could mount it with the battery leads toward the front, like this. Now, I like to keep my battery leads as short as possible, but if I mount it with the battery leads toward the back, then we can see that positive and negative are on the wrong side, so these wires will have to cross over. Positive will have to come over here, negative will have to come over there. But I think there's enough room back here that that's not really going to be a problem, so I think that's going to be my plan. Interesting note, by the way. These 2 mounting screws that hold on this fairing on the bottom are the same 2 screws that mount through the rear of the PDB. Nice touch. So I've trimmed my wires and I've added a little piece of heat shrink tubing on the wire as well, just where it passes through the carbon, just to protect it a little bit. And I've insulated the back of the PDB with electrical tape. Just 1 layer is fine. It's flat, there are no protrusions, so that should work just fine. So it'll mount like this and the 2 wires will cross over, and I'll solder that now. So the PDB is all soldered up. I did end up with a little bit more solder on the positive side than on the negative side, but it'll be fine like that. In either case, there's quite a bit of solder on there. And the joints look pretty shiny. They're nice solder joints, so we should be good to go. At this point, I've just laid the top part in place with the ProSight transmitter in there, so I can see what I'm going to do about connecting power for that transmitter. So I've got this wiring harness that I was using on a previous model, and it has the ProSight connector on the end of it, and an JST on the other end. And I think for this I'm not going to use the JST. This is going to be pretty tight back here, and I don't think I need the extra connector. So I'm going to cut that connector off, and I'm going to solder those wires directly to the PDB, and then this can loop out from underneath the flight controller and plug into the ProSight transmitter. So I'm going to clip those wires and solder them now. Okay, so I've got my ProSight transmitter harness soldered on, and I did redo this harness using some high quality silicone wire right here. The other harness that I just showed you was made of some cheap wire, and you don't really want your transmitter to stop working on you when you're in the middle of flying, so I decided to kind of fix that. And this wire has just higher qualities, less chance of fatiguing. So the way I envision this is that the transmitter will be sitting here on top like this, and this little harness will sneak out on the side here, because remember the FC is going to be sitting on top, so it'll sneak out the side there, come around and plug right in there. And I'm always a proponent of protecting the wiring, so where this comes near the carbon here, might slip a little piece of heat shrink over that just to protect these wires. These are the wires provided by Amimon right here, and they're actually pretty cheap, to be honest. So I may want to protect those the best I can. That's the basic plan so far. And the next thing I'll work on will be the ESCs. Check it out when you order 4 of them from Get FPV. They come in this little box. It's pretty cute. So I'm going to go through and I'm going to, for each of the ESCs, I'm going to tin all of the necessary pads. I will be using the telemetry, so I will use all 3 wires, including the ground, going back to the flight controller for signal, ground, and telemetry. And I will also take 2 of these ESCs and short the little reverse pads, those little guys, right here. You have to solder those 2 little pads together in order to make 2 of the ESCs reversed. So I'll do that to only 2 of them, of course. To install these in this particular model, it is going to be easiest to solder the wires, not the motor wires, but all the other wires onto all the ESCs, all 4 ESCs, with enough wire length that they can reach to the PDB. And then we'll start mounting them in the sides of the frame like this. So there's a sequence here that we have to follow to get these ESCs into place and get all the wires routed correctly. We will have the wires going to the PDB installed first, but not cut to length. We will start at the back and solder the motor wires first, then trim the PDB wires to length and solder them. Then we'll do the front motor wires to the front ESCs, and then lay in the ESC wires from the front to the PDB, because those will overlap the rear ones. So we want to do the rears first and the front. So that's how we'll proceed next. So I've done the tinning and soldering for the 4 ESCs, and I just wanted to show you what those should look like when you're done with them. You want to have nice shiny solder joints, and for 2 of the ESCs you want to have shorted the reverse jumper. That's these 2 pins right here, so that 2 out of the 4 ESCs will run the motors in reverse. And what I've done here, because of the way that these fit into the frame, I've done 4-inch wires for the ESCs that go to the front, and I've done 3-inch wires for the ESCs that go to the rear. And that way it just gives us enough length to be able to trim them off to the length that we need them for the PDB when we get to that point. And like I said, we'll be doing the rear ESCs first. We'll solder the motor wires in place, then we'll trim the wires for the PDB to length. Then we'll do the same for the front, and those will overlap the ones for the rear, and everything will go to the PDB and FC as needed. Now, to accomplish the next step, I've removed the top plate, giving a little bit more clearance to the PDB, and I've removed the connector fairing on the bottom to allow these wires to be loose, because the motor wires pass through those same holes. They go through these little channels. So in order to mount the ESCs, we do have to have the motor wires in place, because we'll actually be soldering those to the ESCs, placing the ESCs in the channels, running the wires back to the PDB, trimming them to length, and mounting to the and soldering to the PDB. So the next thing to do is install the motors. Now, if you recall, for each one of the legs here, we have a little landing pad that goes underneath, and each one of those landing pads is actually unique, because the neoprene pad faces fore aft, and so there's one orientation in which each of these pads will fit, such that that neoprene pad runs forward backward. And in this one, you can see that's the orientation there. One further tip: you want to use Loctite on these screws. Since the screws are passing through this rapid prototype material, which has a certain flexibility or giveability to it, the head of the screw bears down on that material, and so it's not as solid as screwing right down onto carbon fiber. So it's imperative to use Loctite on the screws. And here's a little tip that I think will make installing the motors a little bit easier. First, put the screws into the 3D printed part. Press it into the arm. Then it kind of holds there. You can put your Loctite on and put your motor on and then tighten the screws a little bit at a time until the motor's tightened down. It makes it easier to organize the positioning of the three different parts together as it's being assembled. Okay, the motors are in, but there are three things I want to mention. First of all, the creators of this machine, I believe, recommend the use of Cobra motors. And if you recall, I was just talking about how these pads orient themselves so that these neoprene pads are fore aft. Well, it didn't work out for me. I'm not using Cobra motors, I'm using Luminaire motors. And on these motors, on any of these motors, there are two wider spaced screw holes and two narrower spaced screw holes. And it just so happens that where the wires exit on the Luminaire motors is different than that of the Cobra motors. So in that case, the orientation of these pads couldn't be exactly the way they planned it. It doesn't matter. It doesn't matter if the pads are perfectly forward. In my case, the pads are sort of angled a little bit outwards. It doesn't matter. It's obviously still going to fly just great. I just wanted to mention that. If you're not using Cobra motors, or I guess depending on which motors you're using, you may have to fiddle with the orientation of these four pads before you get it just right. The second thing I ran into is the recommendation here is to glue the wires into place in the channels, and as you can see, I've used tape. I've got a little bit of apprehension about gluing the wires in. I know I could just rip them out if I have a bad motor and, you know, scrape out the channel of whatever kind of glue I use in there, and that's great. But until I fly this thing, I want to be sure that I have everything done right, and until then, I'm just going to use tape. I'm sure the creators of this machine are cringing right now, but this is what I'm going to do until I fly it. I don't like to make things completely permanent until I'm done with the build. However, I will say when this is complete, it's going to look so slick, because look at the way the motor looks when it's installed. The wires just disappear under the frame. Nice and neat. Next, we're going to mount up the ESCs and solder the wires, so we need to think about the wire routing a little bit. The motor wires get soldered first to the front of the ESCs. And I think I'm going to route the motor wires in front of the rear standoffs like this, and then around to the front that way. And when the ESC is in place, and we just put one of these ESCs kind of in place, the wires will run through the back here, out the side, and then around the top, and then down to the three motor contacts at the front of the ESC. Once that's done for the rear motors, we can mount the power wires, or I'm sorry, solder the power wires for each of the ESCs. Those will route right behind the standoff here, the standoff at the front of the PDB, and just loop around to those two pads right there. So here I've done the wires for the first of the rear ESCs, and I just wanted to show you how I did that at kind of an angle, because I want the motor wires to run up at the top of that channel. So when I put the ESC in place, I've got the motor wires running across that way. And then when they're in place, they'll run, as we discussed earlier, between the two standoffs of the PDB. So I have the two left side ESCs installed here with the motor wires soldered. And it looks like a whole lot of wires, right? What a mess. Well, not really. If you really look at it, it just comes down to 4 power wires and the signal wires. So my plan is to loop all 4 of the power wires around the front standoff here to each of the 4 pads here. I've got 2 positive pads and 2 negative pads. And I've got 2 negative wires and 2 positive wires. So it's really not that bad. I'm just going to loop these around underneath these motor wires here, and I'm going to cut each one to length and solder them to each of the PDB pads here. And it doesn't matter that I don't have to have these in perfect groups. In other words, I've got a pair of power wires for the rear ESC, and I've got a pair of power wires for the front ESC, but it really doesn't matter. I've got 2 blacks, 2 reds, 2 negatives, 2 positives, and I'm going to use whichever positives and negatives work out here. I want to keep these wires down as flat as I can because the flight controller goes on top, of course. So I'm going to work on that next. I've got my 4 wires soldered there from the power for the ESCs, and as you can see I just routed them as neatly as I could and kept them as flat as possible. And for those with a keen eye, you may have noticed I put this plate on backwards. The reason I did that is because I want to hold the ESCs in place while I work, and they're secured by these 2 screws, but I didn't want this shelf to be in the way of the work that I'm doing in the back. So I just installed it backwards for now, and I'll switch it around when I'm done. I've completed the power wiring for the ESCs for both sides at this point. The motor wires are all connected, and as you can see I kept the wires as flat as I could so the flight controller could easily fit on top. As we discussed earlier, the motor wires will snake through like this on both sides, and the flight controller fits over top just fine. So this will conclude this video. In the next video I will mount the flight controller and solder the signal wires and complete the rest of the build. So stay tuned.